So we need new ideas, and in this subsection I want to briefly introduce one new idea that at first seems to have nothing to do with parallelism, but it will later enable a different method how to do string matching, and that will be easier to parallelize. And that idea is periodicity. So what does it mean that a string is periodic? Maybe you have an intuition what that means, but I would like you to basically forget that intuition for now and pay close attention to the precise definition that is given here on the slide. So we say a string has a period p. If this is the case, there is a position I, so that if I start, for all positions I, if I read the character at that position and I jump forward by p, I get the same character. Okay. Now this is a definition, and some values don't make much sense. 0 is always a trivial period, because then we're just claiming s of I is s of I. Great. That's always true. And any number greater than n is a trivial period, because we assume, so we require this, well, this is written here, we only require this for positions that are between 0 and n minus p, and if p is bigger than n, then this is empty, so we're not claiming anything. So interesting periods have to be between 1 and length of the pattern. And well, here's an example. This string has a period of length 6, because if you shift the same string by 6 positions, you get matches in all the positions that remain. Of course, we don't insist on matching anything up here where the strings are not really present. Here's a different string that has a smaller period, 3. So if you shift it by 3 positions, you notice that this all matches up if you check carefully. Okay, that's periodicity. It's a simple definition, but it will help us in the end to make a parallel string matching method. One interesting observation that might be obvious from these kinds of pictures almost is this little lemma. It's this statement that a string has a shortest period p if this is a longest prefix that is also a suffix. So we take the prefix that has that leaves off the last p characters, and we want that this is the longest prefix that is also a suffix of this. So we also take the string that starts at p, so this is the string we're looking at here, this is the string we're looking at here, and we like that this is the longest prefix that's a suffix of this thing. Oh my gosh, you have to digest this. So you want to align these like this, so that means there's again this overlap here where they match. And because this is of the same length, I was actually a bit imprecise in drawing this. This should be the same length. Okay. And what that means is there's a connection with our famous and favorite COMP algorithm. The minimal period here, if that is p, that means fail of the final character of the entire string is n minus p. Because that's, well, you have to go back to the definition. Remember from Unit 4, there was this little red box where it said, please memorize this. And that said, fail is Well, you take a prefix of the pattern and you find the shift so that this is the overlap, the longest overlap you can produce by shifting this to the right. That's exactly the same picture, though there's not much thought going into this. You just have to remember the definitions here. So in a sense, periodicity is just a known concept rephrased slightly differently. And we'll continue talking about periodicity a bit more and how to use it next week.